Okay, welcome back. We're on page 426 talking about high availability in the software world. So typically from a software conversion, you can do this load balancing kind of a thing where traffic comes into one machine, then the next traffic comes into the other machine. If you had very simple things that you didn't have to remember. For example, a typical web page, a static web page. We're not talking about, doing anything fancy, just going to look at some web page. If, for example, I went to YouTube and pulled up a YouTube video and it went to this server, and then the second time I pulled up the YouTube video or another YouTube, it went over to this guy, does anyone care? Right? No. I mean, it's just a YouTube video, so if it was pulling from this server or that server, I don't care which one I got. So that's considered stateless. In other words, there's no need for me to know, or not me, there's no need for the machine to know or remember what the previous version was. So in other words, they don't say, oh, well, once you've picked this server, all the traffic's going to go to that server from now on. That's not the way it works. In load balancing, it basically says, hey, the first request goes over here, second request goes over here, I'm fat, dumb, and happy. Okay. Stateful is when I have to remember something. So for example, unlike YouTube, I go to Amazon and I put something in my shopping cart. And then I get the next request, I get shipped over to another server. Well, I don't want my shopping cart to be empty now. So that's stateful. I have to remember stuff. And so it makes it a little bit more complex. So load balancing, this technique here, the load balancing one, is basically used for stateless traffic. And this failover, where you can completely go over to another machine, is usually used in stateful, where you have to be able to store out the state and transfer the entire thing over to another machine. So, one more time, the difference between stateful and stateless. An ordinary web page like YouTube, where I'm not actually transmitting anything to the server at all. I'm just receiving information like a YouTube video. Or a shopping cart, where I am storing some information somewhere on a server. Okay. So, load balance. So how do you spread the load of a server? I mean, this is all done in software. So, as I mentioned, websites originally, when the web was invented, it was really intended for static content. It really wasn't intended for things like shopping carts. And so it was inherently stateless. A request to the web, it didn't matter what machine you went to, it always worked. And that's just the way it was designed. Now, in order to get shopping carts to work, you need some other framework on top of it. The Microsoft framework is called ASP.NET, but I'm not going to get into the details. So there's a framework that's on top of web services that it records where your shopping cart is and how many items are in your shopping cart. Okay. And again, not getting into the gory details. So doing load balancing is a little tough in a state world, because what I would basically have to have is have load balancing on the web server and have load balancing on what would be called a state server, where your shopping cart would be stored over here and these guys would go out and get it. I know it's a little complex, but just bear with me. The failover, failover is sort of like the database thing. If a database transaction would be considered stateful. In other words, that it contains the state. In other words, I send a transaction over, that transaction contains everything it needs to do its work. And it's perfectly okay. In other words, that transaction has nothing to do with what came before it and nothing to do that came after it. So you could send that over and have replication do its trick. So it kind of sort of works. Okay. So they talk about multi-site. Back to this example one more time. I do not want to have my primary and secondary servers in the same room. That's just dumb. If you had a fire, you'd lose them both. I want them separated. But then you're going to have some problems with, how much latency am I willing to pay for? And once again, if you're a Wall Street kind of guy and you're doing, stock trades, I'm probably going to be running a high-speed fiber optic cable from here to here. I'm going to be spending, $1 million to get that cable from here to here to my backup site wherever my backup site is, and I'm going to be spending a lot of money. If you're a bank, oh, what the heck, if it takes 100 milliseconds for your deposit to go through, who cares? So they don't have to spend a lot of money to make this thing go. Bottom line is there should be some separation, some physical separation. Fires and floods and things of that nature don't do you any good if your backup is in the same room. Okay. So the next topic on page 427 is business continuity. And I kind of sort of mentioned that this used to be called just disaster recovery. However, that just doesn't sound very sexy. And what happened is businessmen saw disaster recovery. When's that ever going to happen? We're not going to spend money on that. I mean, geez, how many lightning strikes and floods and fires do we get? And so it just went completely out of their mind. But then, if you renamed it and called it business continuity, they would look at that and go, oh, I see. What you're saying is, if we have a fire or a flood and everything goes down, we're not going to make any money. So it changed the minds of people by just changing the name. So we no longer call it disaster recovery, we call it business continuity. Okay, so we're talking about disruptions in your business. Something happens that makes it so that you can't do your work. So, fire, a flood, a power outage, comm links go down, whatever it is, something's going to mess you up. That's what this is all about. So the first talk about the business continuity plan. So you start with a plan on, how am I going to deal with this? And first would be obviously identifying what the threats are. If you're in California, you might be worried about, earthquakes. If you're in Central Texas, you probably wouldn't be worried about earthquakes, but you might be worried about tornadoes. So yeah, you need to figure out what it is you're dealing with. So you need to create, validate, and exercise a plan. It's very important to do the exercising part. We'll talk about that in a minute. So I need to create a plan that says, in the case of a power outage, we're going to do this. In case of a comm link cut, we're going to do this. We're going to switch over to some old system. In the case of a fire, we're going to do this. Some sort of a list of things that you're going to do. At the beginning, when you're just developing the plan, you can kind of do some wave of the hand kind of things, and then later fill in the blanks with the actual disaster recovery response part. Okay. But as always, if you cannot anticipate what the problem is, you're probably not going to be able to defend against it. Just like viruses, right? If I don't know, where my vulnerabilities are, I can't possibly protect them. Same thing here. If I don't know that there's a possibility of fire somehow that just escaped my mind, well then no, I'm not going to have a plan for how to deal with a fire. I mentioned that exercises are important. Let me tell you some stories, because I like these kind of stories. So we had a great, business continuity plan, and one day it was kind of slow, and I said, hey, let's do a disaster recovery plan. We have an old server that we had just retired. It was still sitting in the corner of the server room. It was unplugged, and I said, hey, let's pretend like that our main server went down, and so I got a stopwatch here. I want you to, bring this old server back up to life, install everything from the backup, and I'm going to be timing you on how long it takes to do this, okay? So we're talking about bare metal. We're taking it all the way down, loading the operating system, getting the tape software. We used tapes at the time. That tells you how old this was. Getting the backup software installed, hooking up the tape backup, doing the restores of whatever the current version is, and then getting it all back up, and I got a stopwatch, and I'm ready to go. So, boom, let's go, doom. So, the first thing we found out is that, I don't really have a cable for that tape deck. I mean, because it's hardwired into the existing server. The next thing we found is, where's the license code for this software? I don't know where it is. So, yeah. We learned an awful lot. We learned that the phone numbers for calling out were ancient, and sending. Here's what we did: we sent it around to everybody. Hey, everybody, update their phone numbers. Make sure they're correct. And of course, nobody did. So dialing up the phone and say, hey, Bob, you need to come in quick. And that's not Bob's phone number anymore. So, yeah, checking the phone numbers, checking the location of install media. Where are the disks for Microsoft, SQL Server? Where are the disks for these things? Who has the license codes? So, yeah, we discovered that we spent more time running around trying to find stuff than we did actually installing the software on the machine, getting it up to speed, and actually doing the backup. The other thing is, where are the backups stored? In a good environment, you would do your backup, but not store them in the same room for the exact same reason. Let's say I'm using tapes. That's probably not the case now, but in my scenario, it was. So do you store the tapes in the same room as the server? No, you want to have them someplace else. Well, how far away are they? I mean, is it just a mile or two away? If so, I just, somebody jumps in a truck, zips on over there, grabs the tapes, and comes back. If for some reason you FedExed them someplace, maybe they're 1,000 miles away, or maybe somebody took them home, that's an off-site option, right? I'll just take the backup tapes home. That's good off-site. Yeah, but the problem is, if you're not here that day, what, am I have to break into your house to get the tape backups? So the speed to get all this stuff, we were slow on finding the right discs, finding the right license code, finding the right tapes. That took a heck of a lot longer than I was anticipating. So it ended up taking us like 3 or 4 hours to bring the system back up. And so we talked about it afterwards, did an autopsy of our disaster recovery and said, how can we speed this thing up? And so we ended up creating a book for every server. And the book contained, a plastic sleeve with install media, with a copy of the whatever the licensing code, password things were, all the information about where the backups are stored, how they're labeled. We end up buying an awful lot of label makers, color coding things, so that when you run over to get here's what happened too. Another story is we sent some junior guy to go get the backup for the server. Well, they're in a hurry, right? So he goes over to this vault where we keep our backups. And so instead of picking the backup tapes for that one server, he grabbed them all. Just took the entire dang shelf and threw them in a cardboard box and took them over because, they weren't labeled very well. They certainly were not color coded or anything. So he was panicking, and so he just grabbed everything and said, here it is. Okay, cool. So that's an interesting thing. So the disaster recovery response part, they have a timeline here, and it's not great. So I'm supposed to be coming up with some sort of a disaster recovery, a business continuity plan. And this happens before things go awry, correct? And then you're going to have some sort of a disaster response plan. And then the event happens, whatever it is, the server dies. And then you're going to implement that plan, and then you're going to resume normal operations, and then you're going to figure out what needs to be tweaked. Because trust me, every time we did this in a plan, in an exercise, every single time, we found something that we could have done better. Like, hey, let's color code the tapes so it's easier to figure out which ones they are. For example, let's talk about color coding the tapes. All right, let's say we have a power outage, okay, and because we did one of these, a power outage and a failure, like I had a lightning strike, and we send the guy into the vault, but the lights don't work in the vault, and so he opens the vault door and it's pitch black in there. And he did not bring a flashlight with him. So we had to stop, go back, find a flashlight, come back. And then, little tiny print on this is for server number 44 and this is for server number 42. Color coding these things makes it, you got your flashlight and you're going, okay, there's the tapes I need. Boom. I'm just telling you, I've done this enough to let you know that you will not have thought of everything. You will not have thought of everything. Okay. This is a good place to start for the 15-minute mark. We'll finish this thing off next time.